Okay, Regions Episode 3, and if you're wondering on which number or which test we're on, it's all on the bottom here. So we're on Joonho 9, 11 to 28. Alright, moving on. In triangle ABC, these are the angles, and they're telling you which expression is true. Alright, so we're talking about triangles here, so we have to draw a triangle. It doesn't have to be for scale, it just has to be a reference point. And we'll just call this angle A, B, and C. I don't know why I'm doing it in lowercase. So angle A is 95 degrees, B is 50, and C is 35. So this tests you on a triangle rule. The largest angle in a triangle is related to the longest side on the triangle. So basically, you just have to find the largest angle in the triangle, and then opposite that angle is going to be the largest side of the triangle. So that would mean that BC here is the largest side of the triangle. The second largest angle is B right here. So 50, opposite 50 is AC, so AC is the second largest, and then of course AB would be the third largest. And they're using less than symbols here, so we're going to go from smallest to largest here. So let's just organize this. So AB is the smallest here, so we'll do AB first. Less than AC, which is the second largest, and then BC is the largest, so that's number 1. So choice 2. Easy. Okay, number 12 says, in a coordinate plane, how many points are both 5 units from the origin and 2 units from the x-axis? So let's just make a little diagram here. And why not label y and x? Why not? So they're talking about 2 units from the x-axis. So it's going to be a set of parallel lines at y equals 2. So let's just say that's over here, and y equals -2. These questions are kind of common sense. Like, if it's 2 units from the x-axis, it's going to be 2 units this way. Like, it's going to be the same distance, and then both ways it's going to be the same distance all around. So these blue lines are going to be the locus points. So yeah, 2 units. 2 units. And now they're saying 5 units from the origin. So it just gives you a point, which is the origin right here, and then they're telling you 5 units from it. So that's going to be a circle, and I'll just place it here, why not? And you can just pretend that this right here, this distance is 5. 5 right here. So now let's look at the locus and see where the locus intersects, and then where they intersects, how many points it intersects. That's going to be our answer. So there's an intersection here, 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 and here. 4 intersections. So choice 4. Number 13, what's the contrapositive of the statement, if I am tall, then I will bump my head? The contrapositive flips both statements on either sides of the then or the comma, and it also negates both terms. So in a letter form, a symbolic form, it would be P, then Q, and if you take the contrapositive of that, it would be not Q, then not P. And they're logically equivalent statements. So let's flip both of these. So if I am tall, then I'll bump my head. So if I don't bump my head, then I'm not tall. So choice 4. So question 14. In the diagram of ABC, Jose found centroid P. By constructing medians, he measured CF, and he found it to be 6 inches. Why not mark that? So that thing is 6 inches. So if PF is x, what can be used to find x? Well, if PF is x. Always the segment stemming from this vertex is going to be twice as long as the other segment, so let's just call CP 2x. So if CP is 2x and PF is x, then the entire thing is going to be 3x. So let's set that equation. 3x equals 6. And now that's pretty simple actually. That's x equals 2. But you don't even need to know this. They're just testing you on what equation can be used. So what we basically did was 2x plus x equals 6, right? So it's going to be choice 2, because we just said, well, if we add CP and PF, that's 2x plus x, which is 3x. I just skipped that step for you. Alright, so number 15, in the diagram below, the length of the legs AC and BC of right triangle ABC are 6 centimeters and 8 centimeters respectively. Altitude CD is drawn to the hypotenuse of triangle ABC. What's the length of AD to the nearest tenth of a centimeter? So this looks like a similar triangles problem. And I was just, because this is one of the hardest questions that you could probably get in the multiple choice, so I just did some kind of work beforehand. So I drew the diagram the way we're familiar with it, like this, with the hypotenuse down like this, and the right triangle up, the right angle up here, and so yeah, I recreated it. So let's try and make this as similar triangles. So it would be x over 6 is equal to, we know that AB is 10, right, because it's a Pythag triple, 6, 8, 10. So that would be 6 to 10. 10x is equal to 36. Divide by 10. X is equal to 3.6. If I'm not mistaken, that should be choice number 1. Number 16, in the diagram below, tangents and secant. So this is a tangent secant question. So you might have remembered in class, wet is the formula that we need, which is whole times external is the tangent squared. So this whole thing is the whole, and well, we need to find CD. And AC is 4, which is the external. And tangent squared is 8. So let's try substituting. The whole thing is going to be x plus 4. So x plus 4 times the external, which is 4, equals the tangent squared, which is 8 squared. So 8 squared is equal to 4 times x plus 4. So let's try and solve it. 64 is equal to 4x plus 16. So subtract 16. That is going to be 48 is equal to 4x. So x is going to be 12. So that's 12. Cool. So 16, let's just proof over here, 64, and that's 8 squared. So yep, our x is choice 3, 12. Question 17, in the diagram of this below, AE and BD bisect, and CAB, that is congruent to CED, that. Alright, so what method can be used to show that ABC is similar to EDC? Well, we know that vertical angles have to be congruent, so those two are congruent, and immediately we have two angles congruent to two angles. So that is just a simple AA is similar to AA proof. So that's choice 2. Number 18, point P is on line M. What's the number of planes that are perpendicular to line M and pass through point P? Okay, so let's make a line. We'll call this M, and point P is on line M. What's the number of planes that are perpendicular to line M and pass through point P? So perpendicular, I don't know, it's kind of like hard to visualize, but I'll try and make the best visualization as possible here. Imagine that this right here that I am drawing is a plane right here. You can imagine that plane, right? That's a plane right there. In fact, I could do that more, and that could show that it's a plane a bit more. Like that. And it is perpendicular to point P. So that's saying that this right here is perpendicular right there. And as you can see, that is basically the only plane that can intersect point P, because this is the only configuration in which a plane can could be perpendicular to line M. And if this plane was anything else, it wouldn't pass through point P, because point P is just one point. So the answer over here is 1. Alright, 19. Square shown. What's the coordinate of the midpoint of the diagonal LN? Which is, by the way, that thing over there. Okay, so first we need to figure out the coordinates of LN. So L is 1, 2, 3, 4, 5, -6, 1, -6, 1, and N is 1, 1, 2, 3, 4, 5, 6, 7, 8. So it's 1, 8. So if L is -6, 1, and N is 1, 8, we need to apply the midpoint formula to this diagonal, which is going to be x1 plus x2 over 2, y1 plus y2 over 2. So let's do that. So -6 plus 1 over 2, 1 plus 8 over 2. It might be a bit funky, but it'll work. -5 over 2 and 9 over 2. They're giving us mixed numbers, so whatever. -2, 1/2, and then 4 and 1/2. That is going to be the midpoint right there. And looks like number 4, choice 4 is the correct answer here. Okay, so number 20 is a bit huge, so we have to shrink it down a bit. Number 20, which graph represents the circle with the equation x minus 5 squared? So we're looking at a 5, -1 origin, because y plus 1. Just with these ones, these circle equations, all you need to know is that the opposite of what they give you is going to be the coordinate. So see this, -5, what's the flip side of that? +5, so 5 is going to be the x-coordinate. So what did they give you here? +1, flip it, it's -1, so the y-coordinate's -1, simple. And whatever they equate it to, this 9 here, just take the square root of it, and that's going to be the radius. So radius of 3 is what we're working with here. So let's try and find that. So we're looking for a 5, so choice 3 and choice 4 are definitely... Oh, well, this might work, but this circle's way too huge. This definitely isn't it. Oh, let's see. 5, -1, yes. Radius of 3. Looks like choice 1 is it. Yeah. Circle equations, just think the opposite. If they tell you to create the formula, it's still the opposite. If they tell you to find the circle or something, it is still the opposite. And the radius is just common sense. Okay, number 21 in the diagram below, there's a right circular cone and its diameter is 8. It's a height of 12. What's the volume of the cone? Okay, now it's time to get out that reference sheet, and it will tell you that the area is 1/3 base height, and that's going to be the volume. And what is this base over here? That means the area of that circle, so it's going to be 1/3 pi r squared each, which is our V value over here. And it tells you that the diameter is 8, so 8 divided by 2, half it is the radius, which is 4, so it's 1/2 times 4 squared times the height, which is 12, and all that times pi is going to be our volume. So 4 squared is 16, 16 times 12 is, let's do the side math here, 3, wait a second, 12, 3, 6, 1, it's going to be 192, so 1/3, 192 over 3 times pi is going to be our volume. You can just put that in the calculator, and that is actually what we're going to do. Be right back. It tells me that it is 201.06 cubic inches, and that's going to be our volume. And it says to the nearest cubic inch, so chop that off, it's 201. Yep, just a bit of calculator work involved in this problem. That's been like the third one this test. Number 22, it's denoted by this equation. What are the coordinates and the center of the circle and the length of the radius? Okay, so let's pick this equation apart. X squared plus y plus 3 squared equals 13. I told you whenever you're faced with the equation and need to give like the center and the radius, just do the opposite. Really, that's all that should be going in your head. Just do the opposite. So x squared, you can't do anything opposite with that, so just put 0. Y plus 3, so they give you plus 3, so just flip it. So the y coordinate is going to be -3. And what about the radius? The radius squared, so everything that this entire equation equates to is going to be a radius squared, not just the radius. So what you have to do is always square root this right here, this 13. So it's going to be rad square root of 13. And I think choice 4 mirrors what we have here. So that is choice 4. Easy. Don't lose any points on circle questions, please. Okay, this question you have to get a little creative if you want to put common sense into it, and you don't. You're like, how the heck are you supposed to do this? I don't get this. It's just a bit of common sense. So they're telling you that this is the system of equations, x equals 4. So yeah, sure. This is x equals 4. Whatever. And yeah, why not call it x equals 4? It's a vertical line. It's vertical. And they're telling you this is a parabola. X squared. It has an x squared in it. That means it's going to be a parabola no matter, as long as it's not just x or x cubed or anything else. As long as there's an x squared only as the highest power in there, it's going to be a parabola. And it seems to me that this isn't going to be some kind of weird side-shaped, C-shaped parabola or anything. So you know that a parabola kind of resembles a cup. And if it was negative x squared, it would be a frown. And so every single point on this parabola, there's not going to be multiple, I should say, y values for every x value. As you go along, every x value has its own unique y value. That's what a parabola is. So no matter what this says, you know that there can't be 2, there can't be 3, but there can be 1 or there can be none. So how do you know which one's which? Well, you have your fancy graphing calculator with you, hopefully, when you take the test. So you can just plot the values on here. So I'm going to do that right now off the screen, even though you can't see me. So I'm doing x squared minus 4x, and I'm going to hit graph there. and I'm going to hit second and table, and it tells me right here that if x is equal to 4, if x is equal to 4 in this equation right here, y is going to be 0. So this is what the parabola is going to be. And I don't know, the parabola might look something like, oh, okay, this is already drawn, but it might look something like that. But at least it intersects this 4 right here. So the number of points of intersection is going to be 1. It can't be 2, it can't be 3. You don't know if it doesn't touch this at all, but it's going to be 1. Alright, common sense. Alright, so number 24 says side PQ of PQR is extended through Q to point T, which statement is not always true. Alright, PQR, PQ is extended to point T over here, which isn't true. So let's go through these answer choices. Number 1, measure of RQT is greater than angle R. That's true, because why? There's a rule, an external angle is always going to be equal to the sum of the two angles it is not adjacent to, so angle P plus angle R equals angle RQT. That is always going to be true. So angle RQT is greater than angle P, that's also not true for the same reasons. Number 3, whoa, it's the same exact thing as this. It's a coincidence, alright. So we know now that choice 3 is not true, and that only leaves choice 4, measure of angle RQT greater than measure of angle PQR. It is necessarily not always true, because you can have triangles like that, and that external angle over there is smaller than that obtuse angle. So, yeah. Oh, okay, so this is one of those questions where you just look at it, and you just gotta know your constructions, man. And that is choice 3, because you start from here, you make an arc, then you start from, let's make it a bit clearer, then you start from these 2 points, and then you make 2 more arcs that intersect, and boom. That, you just have to know your constructions, and you just gotta know what it is. Okay, we're on the home stretch now. Last 3 questions in part 1. Let's do this. Which equation is a line perpendicular to the line whose equation is 2x plus 3y equals 12? Let's put this in a form where we can digest it. So let's subtract 2x from both sides. So it's going to be that. Then let's divide 3. So y is going to be negative 2 over 3x plus 4. So our slope over here of the line given to us is negative 2 over 3, but we need a line perpendicular to that. So it's going to be the negative reciprocal, which is going to be a slope of 3 over 2. And now we have to go through all these answer choices and determine which one could possibly have a slope of 3 over 2. So let's do that. So let's start with choice number 1. 6y is equal to negative 4x plus 12. Negative 4x plus 12. Let's divide 6 from both sides, so we'll end up with negative 2 over 3x plus 2. Our slope is not 3 over 2. Cross that one out. Choice 2 is going to be 2y is equal to 3x plus 6. Divide 2 on both sides. We're going to have y equals 3 over 2x plus 3. Hey, our slope is 3 over 2, so it checks out. We don't need to check all the others once you found your answer. It's just choice 2. Alright, 27. In ABC, point D is on AB. Alright, geez, another triangle graph. Okay, whatever. Whoa, great triangle. Alright, A, B, C. Point D is on AB. Point E is on BC. Such that DE is parallel to AC. Alright, so DE is parallel to AC. If DB is 2, DA is 7, and DE is 3, what is the length of AC? Ooh, similar triangles question. Triangle DBE here is similar to triangle ABC. So what are we going to do? We're just going to use similar triangles. So we're going to do this left side to this side, and then this side to this side right here. So that's 2 over 3. So DB over DE is equal to BA, which is 7 plus 2, 9, over X, AC. So now we do our stuff. Boom, boom, boom. X is equal to 13.5. Choice 4. Last question coming up. Oh, okay. This one is hella tough. In 3-dimensional space, 2 planes are parallel and a third plane intersects both of the parallel planes. So let's draw our planes here. Our plane, and let's see, this right here is a plane. Let's draw another plane parallel to that plane. Try and get it as parallel as possible. And I don't know, we'll color this in with something different. Whatever. So these are parallel planes. So that means this is parallel to that. A third plane intersects both parallel planes. Wow, okay, so how do you draw this? I'm just going to draw it like that. Like so. And that is our third plane that intersects. Let's just extend it a bit. Yeah, we'll just extend that a bit, and that. I'll color it in like that. Boom. The intersection of planes is, alright, the intersection, it produces a couple interesting things here. The intersection is just this line over here and this line over here. And if you know your rules on 3 geometry, these lines are parallel. Whoa. Alright, cool diagram. So what are these? The intersection is a pair of parallel lines. And where is that? It is choice 3. End of part 1 of our Joonho 9 Regents. Congrats for making it this far. I've been recording for 52 minutes. Wow. I really need a break. See you guys in the next video.